I'm streaming. It's getting warm. We're going to. It's whew. It's Q&A Friday. So, yes. All right, Q&A Friday. Welcome everybody. Tom Dimitrovich here, and very happy to. I just hit this button. I'm still having some issues, so hopefully I am streaming right now. Having some issues with my desktop. Don't know why. But in any case, we are Q&A Friday. I just got off a task group meeting. Just got off a task group meeting and discombobulated. That's a word. So I'm going to take a look at so I don't know what you guys have been out there doing. I know last week, I don't know if I went live last week or not. Did I do a Q&A Friday 1 week ago? Take a look. Last one I did was September 10th. So I don't think so. Because what was I doing? That's right. I was at the Eastern section meeting last week where we talked about, I did a presentation on Friday afternoon, right after lunch. And that was I did it on arc flash, incident energy, and the National Electrical Code. Sort of went through all of the different areas in the National Electrical Code that are impacted by, or that try to address two key words. If you think about arc flash, incident energy, and all that jazz, two things you got to worry about: severity and likelihood. So we take the severity of an event. From an arc flash perspective, we understand severity is measured in calories per centimeter squared. So my presentation looked at what are the code requirements that help reduce the severity of an event. And then I also looked at what are the code requirements that help reduce the likelihood. Things like signage help reduce the likelihood, raising awareness. Things like barriers, line side barriers that we see in 230 for services. And working space in 110. Working space helps reduce the likelihood of an event. Why? Because if I can give my electrical worker more space, then the electrical worker will have a easier time or have enough work to possibly reduce the likelihood that they'll trip, fall, all the other good stuff. And then also disconnects, any of the disconnect requirements that we have in the National Electrical Code increase the likelihood that an electrical worker can easily establish an electrically safe work condition. So I reviewed all of those topics on Friday with the Eastern section. Great meeting, Eastern section of the IAEI. What I love about the Eastern section is they challenge you. They challenge what you say. We should always challenge each other because, I mean, the hardest part is to admit when you're wrong, when you're working through things, but not everybody is right. So, and I always remember, that's a disclaimer of everything. Everything that I say on my channel, my opinion only, not the opinion of anybody else. And can I be wrong? Sure. That's why you got chat. And I wish I had the chat. I don't have the chat. I got to figure out, where's my chat? I need my chat. Where is my chat? I have to go to Live Studio to see the chat on Restream. So otherwise, I don't have the chat. At least I don't think I have the chat. No. Anyway, I can't see chat. Maybe I'll go out to the YouTube studio. I'm live right now on YouTube studio. I can check the chat there, and I can open. There we go, Muhammad. There we go. Good morning, and friends. We got great to be here, William Snyder. Thank you very much. I'm flying blind, which you can sort of tell here because I am. I wasn't really ready, but I said I got to get going. So I don't know why I wanted to go to LinkedIn, and I went to Netflix. Don't ask me. And for some reason, my Google Chrome will not open. So I'm working out of a completely different browser, which is really a pain in the rear end because it I don't understand why it just won't open. But anyway, we're going to take a look at some of our questions. So I got to get over to. I had a question. If you had an existing panel board rated at 10K and the engineer shows the available fault current to be, say, 26K, can you knock it down with fusing to keep the 10K rated panels? William. Okay, so here's the thing, Mr. Snyder. What you're trying to do is engineer a series rating, and I'll tell you that obviously if you have a 10K panel board, it doesn't have fuses in it. It has molded case circuit breakers. So what you will want to do in that case, let me show you something. Now my browser's all screwed up. So series ratings. So here's the thing. And when we use up, over, and down to protect a panel board or protect a piece of equipment, I can use up, over, and down for some equipment, not others. And the reason is because if I'm protecting a device that's downstream that also tries to open the circuit, and like a circuit breaker would, right? Here's what's happening. We call that a dynamic device, a dynamic impedance. So what basically happens is I have let's say I try to use up, over, and down with a fuse upstream on just a generic panel board that has a circuit breaker in it. I have to show that my fault current will not have the downstream device begin to separate its contacts. Why is that important? Because when a device downstream begins to separate the contacts, I'm adding a dynamic impedance, which overall reduces the fault current that I'm trying to interrupt, which will impact the response time of the upstream overcurrent device. So, in general, whenever you're looking at protecting a piece of equipment, we'll use the terms dynamic or static devices. What's a good example of a static device? If I have a fusible switch in front of a busway, if the busway has a rating, say 10K, I can use up, over, and down to show the RMS current is reduced that will pass through the busway. Busway is not actively trying to open, it's just withstanding and trying to carry the current. So I can use that method to say I am reducing the fault current for that bus. But I can't if I'm trying to protect a panel board that has a circuit breaker, because the circuit breaker, obviously, if it's 10K, my fault current is going to be greater than 10K. Am I in the instantaneous region? Absolutely. Will the circuit breaker start to part its contacts and try to clear the fault? Absolutely. That dynamic impedance will reduce the fault current. So what we rely on when we're dealing with circuit breakers and components like that are active devices, we rely on tested pairs. So what you could do, William, is, and you're right, Robert, it's let through current, it's the up, over, and down method, and the RMS versus the peak. What you will want to do, and I'm just doing a search on the web and I'm looking for a UL document. Here we go. Yeah, so I'm looking for a UL document, and let me just throw this up. So, and I'm just going to bring this over to just set it there. Thank you. So I'm pulling up this panel board and switchboard short circuit current ratings. 1 second here. I'm gonna take me out of the picture here. I think I can. All right, so take a look at this. This is a document that's published by UL, talks about panel boards and switchboard short circuit current ratings. And we'll talk about the field marked, replacing an overcurrent device. We talk about fully rated systems, series rated systems, which is 240.85. And what you're trying to do when you talk about using the up, over, and down method, you're trying to engineer a series ratings. So if, let's just take a look at 240.86. 240.86 tells us for an engineered series rating, okay, the series rated combination devices shall be selected by a licensed professional engineer engaged primarily in the design and maintenance of electrical installations. The selection shall be documented and stamped by the professional engineer. The documentation shall be available to those authorized to design, install, inspect, maintain, and operate the system. The series combinating rating, including identification of the upstream device, shall be field marked. For calculated applications, the engineer shall ensure that the downstream circuit breakers, which is what you have in your panel board, that are part of the series combination remain passive. And there's the text. Remain passive during the interruption period of the line side fully rated current limiting device. And I'll tell you, because of that language, it makes it almost impossible for you to engineer series ratings. So what you're looking for, take any manufacturer. So and the only manufacturer that I'm aware of out there is Eaton. So you go to Eaton series rating chart, panel board and switchboard series rating information. This is a document that we publish, and there may be other manufacturers out there that actually make equipment. I'm not sure. Maybe. I don't know. They are not my vocabulary. Anyway, just joking. Any manufacturer who makes panel boards and switchboards, etc., will have a document like this, and I'll show you. Okay, so here is your series ratings tables, and you know what? I do have a PowerPoint on this. I know I'm a little discombobulated, but I'm not that discombobulated. So technical presentations, and I file this one under basics because it is basics, and let's go series ratings. And let's see what I got. All right, because I know that I have some tables and I explain this. I explain this to people. So let's take a look. Right. So we're talking this type of deal. But in your case, you probably have a whole panel board. So this 65K device right here, this is 65K, and what you're basically saying is I have a main breaker and I have branch breakers. Whoa, I can't draw like this at all. Look at that. Boy, that looks good, doesn't it? All of this is at 10K, and you want to put a fuse right here in front of this to say that this fuse protects that equipment. Now, what you would want to do is go to the documents like what I'm showing here, right? Panel board, switchboard, series ratings, and you would find your main breaker. Actually, you want 2 levels. I'm thinking you'll want 2 levels. Main devices, breaker series ratings, breaker. I don't know if anybody out there used a, have you ever used a CB? There we go, triple series ratings. So if you look at main fuse class, and then you have the type of breaker and then the branch breaker. So you have your main and your branch. So you want a triple, you want the fuse protecting all three of those. So you want to make sure that you go back to manufacturer's instructions on this information, because on these applications, because you've got to follow the manufacturer's instructions and make sure you're doing it correctly. So the tested pairs by the manufacturer are going to be what you need. And William, I'll tell you that if you just go breaker 1.9, what's your 1020, right? So what you'll need to do is contact the manufacturer and say, what is the fuse that I can put upstream to increase the short circuit current rating? Because it is a breaker application, you've got to rely on tested pairs. That's the only way that you can get that done in a mold. And now, if it's a power circuit breaker, obviously I have an instantaneous that would be high enough. But I'll tell you, if it's a circuit breaker, you would not, to say that it's not going to be going into an active mode like it says here, that it's going to remain passive, you would have to show that your clearing time is so fast that you're below the trip curve of the circuit breaker. And then I would argue you're probably not exceeding the interrupting rating at that point. Just think about it. You're exceeding the interrupting rating, which means you're well into the instantaneous of that circuit breaker. I don't know how you can do it outside of a tested pair. So, long-winded way to answer that one, but that's all I have to say about that. Hopefully that helps. I don't know if it did or not, but it was the best I could do with what I got. Why then can we not use current limiting fuses to protect equipment rated less than fault current available? Can you address that? Okay, Mohammed, do people still use CLF, current limiting fuse, or up, over, down? We generally don't recommend it based on what Tom just mentioned. Yeah, for Mohammed, we don't recommend that for breakers. You can do that for a static device like busway, cables, other equipment that will not try to interrupt the fault current. So we can do that in some cases. To blanketly say we cannot use up, over, and down is not something that I would say. I would say for, if you have an overcurrent device like a breaker downstream, engineering the series ratings is almost impossible. Busway, cable, power distribution blocks, things like that, they don't actively try to open. They're there to just carry current. You're golden. Up, over, and down every day of the week. All right. Why then can we not use current limiting fuses to protect equipment rated less than fault current available? Can you address that? And I think I just did. Series ratings are for the assembly only. Series ratings are for the assembly. Series ratings are for the assembly. Robert. Series ratings. You know what? I think I see your point. I think when we use the term series ratings, we're always thinking about overcurrent devices. So, Robert, I think I understand where I'm buying what you're selling here. Are we talking what? Hold on, man. Series ratings. Let's take a look. This is a good question. Let's go back to 240 again, because it says where a circuit breaker is used on a circuit having available fault current higher than the mark. A good point, Robert. So when we say series ratings, we're specifically talking about a circuit breaker, because it says where a circuit breaker is used on a circuit having an available fault current higher than the marked interrupting rating. The The other areas, when we talk about using up, over, and down, it's not a series rating, because series rating is only for circuit breakers. But I have a short circuit current rating, which is really a 110.10. So let's take a look at 110.10. 110.10 says circuit impedance, short circuit current ratings, and other characteristics. So when I have a short circuit current rating, which is not a circuit breaker, remember, there's a difference between, I feel like my cousin Vinny, identical. There's a difference between an interrupting rating, and then when you exceed the interrupting rating and you want to use current limiting fuses to provide the protection or protect the equipment, you are into a series rated system. There is a difference between that. I just turned my heater on. There's a difference between that and a short circuit current rating, which is a 110.10 requirement. So if I have a piece of busway that has a short circuit current rating of 10K without an overcurrent device upstream, I could engineer a short circuit current rating based upon a line side fusible switch that would provide my protection for that busway using the let through curves. Understanding, when I say let through curves, what do we mean by let through curves? Let's, I know I just closed it, but let's show that. I got to go back to technical presentation basics, and I will go to, I'll go to SCC. Do I have it in SCCR? I should have slides in there in SCCR. That's a good question. That's really a good question. See, do I have, no, I don't, I should have it there, but I don't. Current limitation. Let's go to the current limitation presentation. All right, so yes. So here's what I'm doing. In current limitation, remember what I'm doing when I am applying a current limiting device. I am taking this first half cycle. That first half cycle, which is, right here. This is the first half cycle. I am trying to limit that peak. I'm reducing the peak, and I'm reducing the amount of time I let the current flow. So in current limitation, I am reducing the force on the power distribution system. So what does that mean from a short circuit current rating perspective? Let's run this example. I have 26,000 amps passing through a conductor, 2-watt conductor. I have one cycle of fault current flowing. What is one cycle? Let's go back to my diagram. What is one cycle? One cycle of current would be everything. That is one cycle. I got one half cycle above, one half cycle below. I am going to let one cycle of fault current flow in this example, and let's take a look. Hold on. How do I play the video? I got to take my pen off and hit this. All right, that didn't work. Let me go to my videos, and I got to go to cable whip. Man, the cable limiters, backgrounds. Where's my cable whip? Archive medium voltage cable limiters, transferred videos. Is it transferred videos? I hate when stuff doesn't work when you want it to work. I'm telling you, I'm having computer issues. I'm not sure what's going on, but it don't look good. So let me just let me find this. I got videos. Let me go back to, where is my, why does that not work? play, next, zoom, all slides, screens. Backgrounds, captures, cable image, transferred videos. Cable whip. Let me go back to documents, and I'll go to technical presentations and do a star.mp4. MP4. Thermal mag, MPH surge. Jeez, oh man, I don't have my videos. Cable whip. I'm searching for cable whip now. Anyway, I don't know why I can't play that video. Let's try another PowerPoint. Basics. Let's try this one. Basic short circuit currents. Maybe it's in short circuit currents. Let me try that one. Whip, cable whip, cable whip. Looking for the cable whip. Here we go. Let's try this one now. Same slides, different day. Did do that. All right. This is what happens when you're live. There we go. Get it back to the beginning and get me out of here. Sorry. All right, that was one cycle. That was one cycle of current flowing through the conductor. So one cycle of current flowing through that conductor. That is what you get. This is a slow motion of a different shot, but that's basically what's going on. You can see how that conductor is thrown, and that's the magnetic forces and the heat that's generated. So then what we do is we do the exact same one, but this one demonstrates what happens when you have a current limiting device in the system. And let's run the example. So we put an LPS 200K class RK1 fuse. I'm going to get myself out of the picture because I need you to closely watch this conductor to see the impact that what current limitation has on the circuit. So here we go. You ready? I'm going to get me out of the picture. I thought I could do that easily. I thought I had a button for it, but I don't. So let me get me out of the picture. Here we go. And action. I'm going to do that one more time because you probably missed it. Watch over here. It barely moves. Absolutely barely moves. And the reason is because what I am doing is I am taking that first half cycle from a doozy to just a little blip. I've removed the magnetic forces and I've removed the heat. And so what we want to do when we're protecting equipment, like that conductor, I'm protecting that conductor from short circuits. How am I doing that? By what we just saw. I'm leveraging the power of the current limitation. I've reduced the peak and I've reduced the amount of time I let it flow. So that basically makes sure that I am providing a protection. And if it did not see 10,000 amps of RMS, right? It didn't see the peak current that you would have seen if you had a fault that was 10,000 or greater than 10,000 amps. It saw something much less. And the translation is in protecting the equipment. So that's basically what you got going on there. Really good question, though. I never really looked at that concept that a series rating is only associated with a circuit breaker. SCCR is rated wow, we got a bunch of questions in here. Hold on. Does this relate to current led through? Some busway might have breakers as plugs, so something to keep in mind. Absolutely right. So if your busway has a breaker as a plug, you can change that breaker out. There's plugs that you can put in that have a fuse in it if you need a higher short circuit current rating. So there's a lot of things you can do there as well. And sometimes the breaker will get you there. If it's a current limiting circuit breaker, which they do make them, we do make them, you can use the same process if you're using your circuit breakers. All right. One example, equipment rated 5,000 SCCR, 8,000 amp fault current available. Use current limiting fuses to protect the equipment. Sorry if you addressed this, but can't a current limiting fuse be used to lower the available fault current? We have done this for equipment. I'm curious if this can be done for panels. And Chris, that's what we're talking about, Chris. So for a panel board, you can't the reason you can't use the up, over, and down to reduce that fault current is because of dynamic impedance. Now, here's another mistake. I got to talk to you about this one too. Because of what you just said, you made the statement about let me do this. I'm trying to find a decent one-line diagram, because here's the other issue I've run into, that in some cases I've had individuals who will say that all they do is put a main overcurrent device, which is a fuse, which will reduce the fault current, RMS, throughout the entire power distribution system, which is not right. And the reason is, and I'll show you the reason. Let me show you something. We'll move some things around here because I just have to, let's say that the I short circuit here, and let's just move that to that and then reduce the size of that a little bit. All right, so I just want to make sure. So the short circuit current at the secondary of this transformer is 5,000 amps. Let's say, for example, the transformer wasn't there. Let's just, this is the easiest way to remove a transformer. You just hit the delete button. Yep. See, you guys and gals thought that you had to hire electricians to remove transformers. No, you just hit the delete button and it's gone. See? Look at that. Boom, gone. Now this is, let's say that the fault current here is, I don't know, so we have 31,000 here. Say it's 25. Let's say it's 20,000 amps here because of the length of this conductor right here. Now, I've had people say, because of the fact that they have this overcurrent protected device right up here, they say, because I have that limits the current to everything downstream. But that's not the case. And the reason is, when I talk about current limiting devices, I am not current limiting over the entire range of the fuse or circuit breaker. What do we mean? What point does a fuse go into the current limiting region? I've got to look at a fuse curve, and I got to find a fuse curve now. Let's take a look at boom, breaker basics. I go to distribution equipment, and I'll go to fuses. Let's just look at a fuse, and let's grab a fuse curve. Here we go. Here is a fuse curve, and it is. I'm going to not save any of my changes. Delete. I'm going to move this over here. I'm going to delete, and I'm going to delete. So there's my fuse curve. Now, at what point does a fuse go into current limiting region? It is where we cross 0.01 seconds. So if I wanted to draw a line at that point, I would draw it right here. And I'm going to make it nice and fat. That currents above that point move you into the current limiting region of a fuse. Currents below that point are not in the current limiting region. Now, understand please for me that when you're dealing with a one-line diagram, the fault current at this panel down here is less than the fault current in that panel up there. The further you move away from the utility, we add conductors, we add transformers. You can't make the assumption that because I have a fuse up on the main, that it reduces the RMS current throughout my entire power distribution system, because that fuse is not going, depending upon where the fault is in the system, that fuse is not going to respond to the same current, right? So for a fault down at this panel down here in the bottom, I'm going to have 20,000 amps, which may or may not be in the current limiting region of that main fuse upstream. You know, this guy right here. For this 20,000 amps may not be in the current limiting region of that fuse right there. And I've had people say, I reduce the fault current in my power distribution system because I have this main fuse, which is this fuse is going to react to the fault current of 31,400. It'll react differently for a fault current at 20,000 amps, which will be downstream. I hope that's clear. So I apply an overcurrent protective device to protect the equipment immediately adjacent thereto, if that makes sense for you. Now, if this current 20,000 amps is in the current limiting region, could one make an argument that it's high enough that this device will go into current limitation? You could probably make that argument. Again, but it'll depend upon all of the other overcurrent devices that are in series with that. If you have a circuit breaker that's going to start to open, say that was a main fuse, and let's say that this device right here, I'm going to do something crazy. I'm going to do something crazy here. I'm getting crazy now. Group, ungroup. I could say, take that out of the picture, and I'm going to say that I have a circuit breaker right here. Tape outline. If that's a circuit breaker, now my bets are off for that 20,000 amps, because now that circuit breaker could start to add impedance and start to open. So I got to be very, very careful. You must, in my opinion, you limit your exposure to risk of screwing up if you focus understand that this primary fuse is only going to get you anything for that equipment that it's protecting its inside of, nothing downstream. Just keep that in mind. That's opinion by Tom. All right, go back to, let's take a look. All right, sorry if I addressed this, but it's okay, Tom. You're still looking curious. You need glasses, Robert. I'm just saying. Curious what the force actually is. Would it rip conductors out of terminals? Oh, okay. The mass is reflective, small, dramatic, yes, but what is the force? So here's the thought process on that. We have torque specifications for overcurrent protective devices, right? If my overcurrent device has the ability to hold the contacts closed for 30 cycles, the torque on those terminals reflect the testing at those levels of fault current at those clearing times. That's why it's very important that you follow the instructions, manufacturer's instructions on torque. So the torque on all of the individual products for the terminations and the guidance on what size conductors you can put, how many conductors you can put under those lugs. All of this plays a role, whether it is a 30-cycle device or a 2-cycle device, a 4-cycle device. We test it under those scenarios. If we tell you, for example, motor control centers, I believe, are 3-cycle devices. Could be 4, but I believe they're 3. I could stand to be corrected. And if anybody out there knows, please do so. So the fact that I can have a piece of equipment that's rated for, say, 3 cycles at its bolted fault current value tells me that I'm testing it at 3 cycles. All of my terminations, as long as you're following my rules with regard to torque, then you will have a good, safe, solid installation. If you're not following the rules on torque, which is why we have the requirements back in 110 and the importance elevated on torque, I'm not going to pull out those conductors. I'm not going to have an issue with pull out and whatnot. So the other aspects think about the magnetic forces. You have your mounting equipment. You may be mounting the circuit breaker on the bus bar. Do you think that termination of the circuit breaker on the bus bar is an important possible, or could be possibly a weak link if you did not torque that down correctly? I would say that might be the case. So every little component, anything you're bolting together, I don't care if you're putting it on the wall, it all plays a role. And now, do I know what the actual force is? I don't know what the newtons are, but I can tell you we actually test that. Conductors in industrial power panels are often in free air. Yes, I design with fuses to limit. Yeah, amen, brother. Hello from Houston. JP, welcome aboard the Eaton Tech Talk Bus Q&A Friday. Pound Eaton Tech Talk. If you want to get any of these, remember, Pound Eaton Tech Talk. Should SCCR be combined with power conductor binding? Ooh, i.e. rope. Oh, you know what? Very interesting. I'm going to reserve comment on that one because that's a good question. How many tabs do I have open? You know what? I'm telling you what, I had a bunch of stuff open and I just closed a bunch of it. I still have a lot of tabs open, which is probably why my computer is giving me problems. This is interesting. The torque is involved. I thought it was unsure. Yep. Does Eaton ever require bracing, lashing in their gear? Yes, Chris, we do. Bracing and lashing. And in fact, we talked about this last week, or not last week. Eaton, I think we called that lashing. Oh man, what do we call it? Cable bracing solutions. Cable bracing. No, that's not. It's not bracing. It is called. Hold on. I downloaded that. I can show you the document, and it's not called bracing. It is called lashing. Cable lashing. So we do have guidance on lashing. And let's do this. Remember this document, cable lashing in low voltage switch gear. We talk about how it's tied and the rope. That's traditional. And that's, you know what? Look, all breaker frames, short circuit current rate. Oh, man. Okay, yeah. All breaker frames and systems with short circuit current ratings above 65,000 amps, 800 amp ramp, regardless of system interrupting currents. When you have compression crimp lugs, 2 mounting holes, absolutely all of this is directly associated with that video that I showed with the cable whip, right? Because of those magnetic forces, we want to keep those conductors under those lugs, and we have guidance on that in this document, and we even give you, you have your cable, you have, whoops, geez, oh man, cable lashing. So it's cable lashing. And please, if you do any searching on the web, call it cable lashing instead of bracing. So yeah, lashing. Chris, you did. Thank you very much. You did say bracing / lashing, but I stopped at bracing, so my fault there. Good job, Chris. Is there a calculation for the torque? Ooh, no. I don't have a calculation. Nope. You just follow the manufacturer's instructions. It is trial and error. I'm not sure how they come up with this torque. Do you know of any NEC panel meetings in the Philly area? NEC panel meetings of. So Mohammed, no, all of the code panel meetings, if it's a code panel, if it's related to NFPA, it's all going to be virtual. And when they do meet in person, there's two locations. One on the East Coast, which is over in Hilton Head, and the other in California, which is somewhere in California. I can't remember the name of it. San Diego. We're moving out of San Diego. We're not going to be meeting in San Diego anymore. I can't think. Redondo Beach, I think, is where we're going to be at. But what I would highly recommend, Mohammed, and anybody out there, the IAEI meetings. You have local chapters and you have these sections. Right now, we just had a section meeting here in Pittsburgh, Pennsylvania for the Eastern section. We just had our Western section. I believe the Southern section is coming up, and that's going to be in Asheville, North Carolina. What goes on at those meetings? Here's what goes on at those meetings. I'm telling you, it is. You know what? In fact, oh boy, I don't even know if it's on my calendar. I hate when I look. Anyway, here's what I am going to do. I wish I could do this. I'm telling you. Here, hold on. iCloud. I'll go to iCloud because I got to show you a picture from this Western section meeting, and I'll tell you what. So at the section meetings, we have these code panels to your question, and we take questions. And every section is a little bit different. So at the Western section, we have code panels and we have code questions, and we put the code questions up and we answer those. And I got to do an allow here. Jeez, oh man, this is like, I wanted to just show a picture. Hit trust, save. Gosh. So at those meetings, we do a lot of work to help people understand the code by what we call code panels, where we have a question that's asked and we have a bunch of people up there on the web or in the room. And this is Mark Cook. We were at a code breakfast, and this is what we do. I mean, I love this, and I had to get a picture of this because what we did at the Western section, we all sit at our tables. They put a question up there, and we have a contest. We see who can answer. Are you still on It's Bad List? Yeah, I think so. I am. You know what, Mohammed? I think that part of my issue with my computer is I'm on the IT bad list, and they're remotely hurting me here because, and I don't think they're doing it intentionally. I just think we're moving to we updated our Windows system. The security agent on this computer is older, so I think it's starting to shut some stuff down. But in any case, this is what we do. They put a question up on the board, and we have a transponder where we have to answer the question, come up with A, B, C, or D answers, and then we hit the responder, and then they give you points, and whoever wins that table, they get like $20 a piece. So it's games like that, and it's code panels where we're debating and arguing. And Mark Cook was feverishly looking through the code book, and you can see he's got it all tabbed. He's got it underlined. These guys, and they just, it's absolutely amazing to be in the presence of people who care as much as they do and know the code as much as they do, and they feverishly work hard to improve themselves. And you know, Mark saved the day on our panel, on our desk, and he went through. We got to come up with an answer, and then we put it into the transponder, and we didn't win $20, but you know what? We had fun doing it, and it was absolutely a lot of fun. We had a great meeting. We had absolutely a great meeting. And I'm just looking through and see if I can get a broad shot of the this is Chris Finnan was doing healthcare.
Past 3-4 code cycles. It's gone through quite a transformation in the past.
So Chris Finnan was is our guy from on the healthcare. He sits on panel 15. He sits on 99.
And now one question.
And
3-4 code cycle.
So we got a good room full of individuals. He's covering healthcare applications, giving us the history around how NFPA Article 517 and NFPA 99 have developed over the time. So these are your opportunities. So I would highly recommend you go to iaei.org, and let's do that. 12:59. I got another meeting coming up. iaei.org, and then you go to education. Got section meetings, local events calendar, and this is where you'll find they got the Western Massachusetts chapter meeting, Arkansas chapter meeting, September 29th. Man, that's right around the that's next week. Arkansas, you got the Adirondack, you got Alaska. So you can go through here and try to find your local meetings, your section meetings, all that jazz. So I would say find one of those and get it in your area. I probably learned a lot also. Yes, lots of knowledge in that room. Yeah, and I tell you what, I learn all the time when I go to those meetings. And I continue, sometimes it's a humbling experience because when you think you know this book, you start realizing you don't when you see some of these questions. Quicker the answer, the more points. Yes. Rocky Mountain. Yes. Yeah, absolutely, Chris. And the Rocky Mountain group is the ones that put that on at the Western section. That is a great, but it's hard to relate to with both passionate but lonely endeavor. Yeah, absolutely. All right. So it is 1 o'clock, and I know I started late, but I do have other meetings. So hopefully, and I know we didn't get to all the questions. I didn't even get to any of the questions that came in on YouTube. Maybe I'll do another Q&A session next week. So thanks for joining in. I've got to run to another meeting. Thanks for joining in. Thanks for what you do for electrical safety and for the electrical industry. Stay safe, and remember, please stay healthy. All right, guys, have a great weekend. It's Friday. It's Q&A Friday. Make it happen. Thank you, Robert. Thanks, Chris, Mohammed, Kara. Does Eaton have service entrance rated manual transfer switch? Yes, we do. We do have service entrance rated manual switch. If you want, send me an email. I'll get you that information. Thomas A. Dimitrovich at Eaton.com. Or you can go to Thomas Dimitrovich. Or no, you know what? I got a new URL. What am I talking about? Electrical. Go to, you're welcome, Chris, www.electricalsafety.live. Shoot me a note on electricalsafety.live. Electrical safety, all one word, .live. And that'll take you to my site. You can go to About Me, and I believe my Contact Me link is there. So send me a note, and who was it? Kira. Send me a note. I'll get you the information. So thank you, everybody. Thanks for what you do for the electrical safety, all that jazz. I'm out of here. Take care. Stay safe. Have a great weekend.